Hello students, welcome to the online series of Math Class. We are currently doing chapter 1 sets. In that, the topic for today is subsets. So what is a subset? The definition is any set A is said to be a subset of a set B if every element of A is also an element of B. So what is the meaning every element of A? So if you consider this subset is nothing but a part of a set. Okay. If you take a set, its one part is a subset. Okay, its one part is a subset. So its one part is a subset. So subset is one smaller part of a bigger set. Subset is a smaller part of a bigger set. So that is in simple words. Now mathematical definition, a set A is said to be a subset of set B if every element of A means every element of the smaller set, is there in the set B, is there in the set B, is there in the bigger set B. So remember the set bigger is always bigger, and the set subset is smaller. Okay, the subset is always small. Subset is small. So remember this fact. Now A is said to be subset of a set B. A is said to be a subset of set B if all the elements of A are in B. Means all the elements of A should be in B. Okay. So let us take one example. So the set, if you take the set A, this should take as A, this should take as B. Is A a subset of B? How to understand? A will be a subset of set B if all the elements of this subset, all the elements of the smallest set are there in B. Now what are the elements here? Here the element is 1. Here it is there in the bigger set 1. Here the element in the smaller set is 3. Here also 3 is there. So all the elements of A here are there in B. All the elements of A are there in B. Therefore A is a subset of B. So this is true. This is true. Therefore, A is a subset of B. So I hope you understood how we get a subset. Subset is a smaller part of a bigger set. Subset is small, there is a bigger set. So subset means this. So I hope you understood the example. Okay. In other words, now we use the notation. You already have seen the belongs to symbol. We use this for elements to say that a element belongs to a set. Now this symbol, it is almost like C. It indicates the subset. Okay, it indicates the subset. So we are telling A is a subset of B. A is a subset of set B. If any element of A, so if any element A belongs to the smaller set means it definitely belongs to the bigger set. So this is another way of saying this definition. So if any element A belongs to the smaller set, then it definitely belongs to the bigger set. So consider this example here. Now here the element 1 belongs to the smaller set, correct? Element belongs to subset here. It definitely belongs to, if A is a subset of A, then 1 definitely belongs to the bigger set. So 1 belongs to B. So we know that 1 belongs to B. Therefore, A is the subset of B. So we write like this, A is the subset of B. So this is the definition. Now here we use one word implies. This is the symbol for implies. So what is the meaning of implies? Implies indicates the word if then. Means if something should happen, if then. So if I give one sentence, if you go out in the rain, then you will become wet. So this is the meaning implies. If then, we are using the if then condition. Okay, so we can write it as if you go out in the rain implies you will get wet. Implies you will get wet. So it implies the forward condition. So that is the meaning of the word implies. So if using this symbol we can write A is a subset of B if any element A belongs to the smaller set, then any element A belongs to the smaller set subset A, then A implies A belongs to the bigger set B. So this is the definition. This is the definition. We are writing in three different ways. First one is abstract definition. Next we use the symbol subset. Next we use the implies symbol. So these are the three ways we write the subsets definition. So mainly we use this definition. A is a subset of B if any element A belongs to A implies A belongs to B. So if any element 1 here, for example, 1 belongs to the smaller set, then it will definitely belongs to the bigger set. So this is the definition. This is the definition. Okay, so how do we read this? How do we read this? We can read this definition as A is a subset of B if A is an element of A implies that A is also an element of B. Okay, so this is how we read. So this is how we read. If A is an element of A implies A is an element of B. We imply the forward condition. We imply the forward condition. Next, if A is not a subset of B, then we write A is not a subset of B. So this is the notation. Not. A is not a subset of B. If A is not a subset of B, then we write A is not a subset of B in this notation. I will give an example. Suppose there is a set 1, 3 and there is one bigger set 2, 3, 5, 9. You take this bigger set as B, you take the small set as A. Now, is this a subset of this set? Is this a subset of this set? So, it will become a subset if all the elements of A are there in B. Now, you take the element 1. 1 is there in A, 1 is there in A, but 1 is not there in B. 1 is not there in B. Therefore, A does not become the subset. 3 is there, here also 3 is there, but here this one element 1, it is there in A but not there in the bigger set. So if there is any element belonging to the smaller set but not there in the bigger set, then A will not become a subset. So understand the counter example. So here A is not a subset of A. Here A is not a subset of A because the element 1 belongs to A but it does not belong to set B. So this is the counter example for a subset. Next, okay. Next we proceed. Note. Now here we talk about equality of a set. Earlier we know that as two sets are equal if all the elements of A are okay. We know that two sets are equal if elements are equal and elements are same. They have same number of elements and same elements. Now we can use the different definition here. We can use the definition of subset. So what does the definition say? A is a subset of B means A is a subset of B means all the elements of A are in B and B is also a subset of A means all the elements of B are in A. So here we are using the double condition for equality. So what is the condition for two sets being equal? Using the subset definition, it is like this. A is the subset of B means what is the meaning? All the elements of A are there in B. All the elements of A are there in B. B is the subset of A means what? All the elements of B are there in A. Then only if and only if A equal to B. Now this is the definition. So what does this mean? What does this mean? Here we consider this if and only if condition. This symbol is called as if and only if it gives a double implication. Means if this happens then that will happen. If that happens then only this will happen. Means two things are dependent on each other. Okay. The double implication symbol indicates the double implication. Means if this happens, then that will happen. Okay. Then only that will happen. So if I give an example, if the traffic is late, if the okay, okay. Here we consider a node now. Now consider a node. A is a subset of B. Here we talk about equality of a set and we talk about sets being equal. So earlier we know when the sets are equal, the two sets A and B are equal when they have same elements and they have same equal number of elements. Now here we consider a different definition for equality using the concept of subset. So what does it say? A is a subset of B and B is a subset of A if and only if A equal to B. So what is the meaning of this? First consider what they are saying. A is a subset of B. What is the meaning of that? A is a subset of B means all the elements of A are there in B. Correct. All the elements of A are there in B. B is a subset of A means all the elements of B are there in A. All the elements of B are there in A. If and only if A equal to B. Then what will happen? The two sets are equal. Then A equal to B. Now we have the if and only if condition. What is the meaning of if and only if? If and only if means the double implication. Implication means if this happens, then only that will happen. Then if that happens, then only this will happen. So if I give an example, so if I tell, if you understand the topic sets, then you can. Okay. If I give an example, if you listen to the explanation, then only you will understand. What is the meaning of this? It means that if you listen to the topic properly, then you will understand. What is the double implication? You can say the backward implication as if you understand, then only you have listened properly. If you are understand, then only you have listened properly. So it means forward condition, it means backward condition also. If this means that, if that means this. Both sides also, front to back also it goes. So here I hope you can understand the implication. So here what it means? Here it means if A is a subset of B means all the elements of A are there in B and B is a subset of A means all the elements of B are there in A. Then they are equal. Then both sets are equal. A equal to B. The reverse condition is also true. So this is the forward condition. What is the reverse condition? If A equal to B, then A is a subset of B and B is a subset of A. So both the conditions are possible. If this means that, if that means this. So both conditions are possible. If and only if. So that is the meaning of if and only if. I hope you can understand. Okay, so we consider the next note. Every set A is a subset of itself. Why is this? It is because, okay, you see the definition. A is a subset of A. When it becomes a subset, when all the elements of the smaller set, when all the elements of subset are there in the bigger set. So here definitely all the elements of A are there in A, correct? So if you consider this set 1, 2, is it not there in the, is it not the subset of 1 comma 2? It is the subset of 1 comma 2 because all the elements of this are in this. So 1 is there here, 1 is there here, 2 is there here, 2 is there here. So definitely it is a set. So definitely A is a subset of A. Okay, so this is the example. So A is a subset of itself. So any set is a subset of itself because all the elements of that are there in that. Next, empty set. Since empty set has no elements, we agree to say that phi is a subset of every set. So I can say like this. empty set is there in every set because we can have nothing in everything. So if I give an example of a balloon, if I give an example of a balloon, before you blow a balloon, there is nothing in this. There is nothing. After you blow a balloon, there is air. There is air. So first there was nothing. After that, air is there. So what we can say? There is empty set in every set. There is empty set in every set. So if you take the set A, if you take the set A, what you can get? First there will be nothing. Then we can add elements. I can add elements 1 to 2. So is empty set subset of every set? Empty set means nothing. So is empty set a subset of this set? Definitely, because there was nothing here, there is nothing here. So all the elements of this are there in this. Because in this also there is nothing, in this also there was nothing. Then we filled 1 to 2. So the important fact to remember, every set is a subset of itself, then every empty set is a subset of every set. So empty set is there in everything. So nothing is there in everything. Nothing you can find in everything. Okay, so that is the note. Now exercise 1.3, make correct statements by filling the symbols subset or not a subset. So 2, 3, 4, is this a subset? So here we have to check whether the elements in the smaller set are there in the bigger set. So here 2 is there here, 2 is there. Here 3 is there here, 3 is there. Here 4 is there here, 4 is there. Therefore, this all the elements of the smaller set are there in the bigger set. So therefore, this is the subset. So this is the subset. So this forms the subset. Next question. B, A comma B comma C, the set of this, is it a subset of this? So now check if all the elements of this are there in the bigger set. So A is there here, but A is not there here. So therefore, this does not become a subset. So this does not become a subset. Next, X is a student of class 11 and X is a student of the school. So is this a subset? Now, if student of the school means it starts from LKG, UKG till standard 12. So all the students are there from LKG, UKG, first to 10th and 12th. So all the elements are there here, all the students are there. This is one particular student. So all the students of class 11, here class 11 students, all the elements of class 11 students are there here. So therefore, this forms the subset. So therefore, this forms the subset. So this is a subset. Next we have X is a circle in a plane and X is the circle in the same plane having radius 1 unit. So if X is a circle in a plane means it can have one circle like this, 1 unit, 2 unit, 3 unit and so on. All the circles are there. But this contains only circle of radius 1 unit. If circle of radius 1 unit is there, but all the other circles are not there here. So therefore, this does not form a subset. So therefore, this does not form a subset. Next, X is a triangle in a plane and X is a rectangle in a plane. So the triangles are not there in the rectangle set. So therefore, this does not form a subset. So this is not a subset. Next, X is a equilateral triangle in the plane. Is it contained in the set of X is a triangle in the same plane? So if you are considering equilateral triangle, now if X is a triangle means we can consider equilateral triangle. Then we can consider obtuse, acute, scalene, all kinds of triangle you can choose. So this one equilateral triangle is there in this set. It is there in the set. So therefore, this forms the subset. So therefore, this forms the subset. So therefore, this forms the subset. Next, X is the even natural integer and X is the integer. Here, this set, all the elements of this set are definitely there in this set because X is the integer means it contains odd natural numbers also, even natural numbers also. Here integer. What about integer? Integer contains odd, even and also natural numbers. All the natural numbers it consists of. So therefore this forms the subset. So these are the answers. These are the solutions. You can check out the solution. This is the answer. Okay, next. Now we have to check whether the statements are true or false. So first question, set of A comma B is not a subset of B comma C comma A. Is it true or false? Now check whether this is a subset. Here the element of this set A is there here, B is there here. So all the elements of this small set are there in this set. All the elements of the subset are there in this set. So therefore this forms a subset. So what they have given? It is not a subset. So therefore this is false because it is definitely a set, subset. So it is false. Second question, A comma E is subset of X such that X is a vowel in English alphabet. So is this true? Now A comma E is there. What is the meaning of vowel? Vowel is nothing but the set of A comma E comma I comma O comma U. Now are all the elements there. Here A is there here A is there. Next E is there here, E is there. So all the elements of this set are there in the bigger set. So therefore this is a subset. So this is definitely a subset. So this is true. Next third one, 1, 2, 3. Is it a subset of 1, 3, 5? So here 1 is there here, 1 is there. But 2 is there here, but 2 is not there here. 2 is not there here. So therefore this does not become a subset. So this is not a subset. So they have given it in a subset which is false. So this is false. Next, fourth question. The set A is a subset of A comma B comma C. It is definitely a subset because all the elements here are there here. So therefore it is a subset. So this is true. Next, the element A belongs to the set A comma B comma C. This is also true because when we indicate an element belonging to a set, we indicate A belongs to this means this element belongs to this set. Okay, the element belongs to this set. We indicate this symbol for subset. So we indicate this symbol for subset. So when you indicate this, this definitely should be a set. Okay, it should be a smaller set. It should be a smaller set. So A comma B comma C. So A belongs to A comma B comma C. A is an element of this set. So you have to understand the distinction between element belonging and set being a subset. So that is the main difference. So this is also true. Next, sixth question. X is a even natural number less than 6. Is it contained in X is a natural number which divides 36? So if this is a even natural number less than 6, what are the even natural numbers less than 6? We have 2, 4. 2, 4 are the only even natural numbers less than 6. And X is a natural number which divides 36. Which are the natural numbers which divide 36? 1, 2, then 3, then 4, then 6, then 12, then 36. So these are the natural numbers which divides 36. So here definitely here 2 and 4 are there in this bigger set. 2 and 4 are there in the bigger set. So therefore it forms a subset. So this is true. So these are the answers. So these are the answers. So therefore these are the answers.